Good morning, all of you. So, can someone respond whether you can hear me or not? Mm. Okay, good morning. Can all of you hear me? Can someone respond? Yeah, okay. So, let's start the today's lab session. So, today's lab session actually it is a very simple one. So it is based on sorting algorithms. So, as you know, there are several sorting algorithms in your syllabus. So we call this one as simple sorting and advanced sorting. So simple sorting has uh, three algorithms: bubble sort, selection sort, and insertion sort. And you have advanced algorithm, merge sort, and quick sort. Okay, if you are getting a simple algorithm, that means bubble sort, selection sort, and insertion sort are based on iterative method. And the advanced algorithm, merge sort and quick sort, like a heap sort, there are several hot sorts available: merge sort, quick sort, heap sort, likewise. Those are based on recursive algorithms. That means recursively call the function again and again to perform the sorting mechanism. Here we use iterative method. Okay, today you will learn these three basic algorithms, simple algorithm. That means bubble sort, insertion, selection sort, and selection sort and insertion sort. Okay. uh, Quickly go to the first one. Go to the lab sheet 5. Here you will get abstract data type. This abstract data type you need to fill. Here you already filled so many abstract data types. Here also there's a class called simple sorting. And this is there is an integer type array called a. It is referring to the array. And likewise there is a number of element, int n elements. And there is another one called this is a simple sorting. This is a constructor. Here you have to initialize the array according to the user preference. Assume that user need the size of 10 array, you need to construct the array. You already did this one in previous lab session. And insert value to the array. So you already did this kind of one in the previous lab session. Okay. And display mean show the array content. You already did this kind of one in the previous lab session also. And here and onwards the new things. First one is, it is a private uh, method called swap. What actually happened there, you have to pass two indexes. You need to swap these two indexes inside the array. Okay. For an example, if user enter 5 and 8, then fifth element and the eighth element, the values should be swapped inside here. And here this one, you have to fill the bubble sort mechanism. How to fill using the bubble sort, and how to fill the body using the selection sort, and how to fill the body using the insertion sort. Okay, then let's start. First of all, open the NetBeans IDE. Okay, now go to the file, new project. Here you can left side Java, right side Java application, and next. After that, what you can do, let's say simple sorting. Here, what is meant? Simple sorting. Simple sorting, let's say application, app. Simple sorting app. Because we need to create a separate class, therefore I use simple sorting app. And finish. Okay. Now this is your simple sorting app. So this is the main class and this is the start of the main class and this is the end of the main class. Okay, after the end of the main class, you can just copy this code, abstract one, and paste it here. After that, you can fill out the codes. Class simple sorting. Okay, first one is private int a. It is reference to the array and number of element. Okay, this is the constructor. Okay, how to fill the constructor? You have to initialize the array with whatever the user passed number of elements. Sorry, user passed size of the array. Okay, here what you can use this dot a is equal new int whatever the user entered value. After that, what you have to do, an n elements, this dot n elements initially 0. Now you initialize the array. After that, number of element initially 0. Anyone has problem? Okay, then go to the insert value. Put an element to the array. Okay, how you can put the elements? You can directly insert this dot that means this dot a number of element location. Initially 0 means 0th location. Put the 0th location whatever the user entered value. Here value, put it as value. After you insert, what you have to do? After you insert, you need to increment the number of elements, this dot number of elements by 1. Increment the number of element by 1. Or otherwise here you can use the plus plus also in the one line. Here I wrote it in the 2 lines. Then okay, and there is another one. What happens if the array is full? Assume that size is 10, all 10 elements are now full. Then what happens if you try to insert another one? Then it will be array out of bound. Therefore, before inserting this one, you need to check whether array size is full or that means array is full or not. How to check this one? You can use if number of elements you have to check whether it is equal to the array dot length. If number of elements equal to the array dot length, which means the array is full. Then what you can use, system.out.println array is full. Then after that return. Return means do not execute this one. That is why I put return. So if you don't like to put return, then put these two lines in the else part. Anyone has problem up to here? Okay, let's go to the next one, display. Okay, how to display the array content? You can use simple for loop. So before put in the for loop, you can use sout array elements, array of content. After that, you can write the for loop for int I equals 0, and after that I less than, you have to go to the number of elements, this dot n elements, and j plus plus, sorry, not the j, I plus plus. And display the array content, you can write sout how to display the array content. You can use this dot a I location, print the I location, after that put some space, empty space. Okay, I do not use the ln, I just use the only print, because I need to print it in horizontal way, not the vertical. Okay, after you print, go to the next line, sout just only sout. After you print everyone, go to the next line. Okay, next one is swap. I think you already know how to swap element. Okay, that means assume that now this is the array say 2 3, this is the array, and now you need to swap the elements the array location 0 1 2 3 4 and 5. 1 2 3 4 5 6, array size is 6, start from 0 to 5 array location. Assume that now you pass the array as index number, you need to pass swap 1 and 4. How to swap 1 and 4? Take whatever the value to a temporary location, after that put the other value to here, and from this value put the temporary location. So that is a simple way of swapping. Okay, how to do this one? First of all, you need to take the temporary location in temp. After that, what you can use, temp is equal whatever the index value you like, array, let's say first in index number 1, you put this location to the temporary value. After that, what you can use? You can use that array index 1 location is equal array index 2 location. Put that 2 location to the 1. Put this 2 location to the 1. After that, what we have to do? After that, array 2 location should equal the first location. 2 location should equal the first location, but first location you already changed. The value has been changed. Therefore, first location value is already available in now temporary location. So do not use this one. You need to use the temp. So this is the simple swapping mechanism. Anyone has problem up to here? Okay, let's start the bubble sort. Sort the array content according to the bubble sort algorithm. Now we are going to sort the array content according to the bubble sort algorithm. Okay. Now first of all, see how the bubble sort works. So this is the bubble sort. So bubble sort, here it is check the first two element, then it will be swap. After that, second two elements, now 3 is the smallest, so swap. After that, check the 1 and 6, 1 is smallest, swap. After that, 6 and 8, 6 is smallest, do not swap. Then 7 and 8, 7 is smallest, swap. And after that, 2 and 8, 2 is smallest, therefore swap. After that, 4 and 8, the 4 is smallest, then swap. Okay. Now you did that. Last number, largest number come to the end of the array. So do this one again up to here. After that, up to here likewise. So this is the simple bubble sort mechanism. So I will little bit explain this one using the whiteboard. Give me 1 minute. Okay, now can you guys see my whiteboard? Can someone respond whether you can see my whiteboard or not? Okay, let's take some example of the array. Zero, 1, 2, 3, 4, 5, 6. That means array size is 7. Size 7. Assume that you have numbers 3, 2, 7, and 5. You have 4 numbers. Okay. Now those are empty. That means number of elements, n elements, 1, 2, 3, 4. N elements 4. Okay. Now how this bubble sort works? It starts from this location and check whether next one is smaller than this one. Yes, you know, start from this location, next one is smaller. Yes, if it is smaller than this one, then swap. Then 2 come to here, 3 come to here, and 7 and 5 as it is. Okay. Now, again, it starts from, sorry, not the again. Now you check the 2 and 3. So here you come to this location and check it with the next location. After that, only these 2 swap because it is smaller. After that, this one come to the next location. I'll draw it in this one. First is check this one. After that, it come to this location. Now it is 3. Now check whether is the next one. 3 and 7. 7 is larger. 3 is smaller. Therefore, do not swap. Put it is as it is. 2, 3, 7, 5 as it is. Then it go to the next location. 7. Now it is checked with the largest one, next one. Now you are in the 7th location, the second location, 7 and 5. 5 is largest, therefore you need to swap. Therefore, 2, 3, 5, and 7. Okay. Do you need to go to the next one? If you go to the next one, what happened? You are going to try with an empty value. Do we need to try with an empty value? No, therefore do not go to the last element. Stop this one before the last element. Okay. Now what happened? You can identify the largest element, the largest number come to the last. When one part is over, the largest number come to the last. Then what you have to do? Then do this one again. Because largest number come to the here. Then do this one again. Now green color mean first part. After that, do this one again. I'll put it in red color. 3. Check whether, sorry, 0th location. Check whether 0 and 1. Again, this one and this one. Yes, this one is already smallest. Therefore, do not swap. Therefore, do not swap. 2, 3, 5. Actually, this is already sorted, no? So let's say different values. This one is already sorted. No, I think it is not the best way for the explanation. Let's say 4, 8, 1, and 3. Okay, let's start it again. Go to the first one. Compare with the next one. It come to the 0th location. Compare with the next one. 8. 8 is largest. 4 is smallest. Therefore, do not swap. Put it as it is. 1, 3. Then go to this location. Now this one and this one. 8 and 1. 1 is smallest. Therefore, you need to swap. Then 4, 1, 8, 3. Then come to this location. Okay, when you come to this location, 8 and 3. 3 is smallest. Therefore, smallest value should go to here. Largest value should go to here. Sub these two. 4, 1, 3, 8. Okay, do we need to go for the last one? Then you need to sub with an empty value. Therefore, do not go up to the last one. Do not go last one. Here. Now you can identify the largest value come to the end of the part. That means largest value is in the value. Now this part is already sorted because largest value here. But these ones are not sorted yet. Did you identify? Then what you have to do? These 3 you need to again sort. These 3 you need to again sort. So what you have to do? You have to do it again from beginning. Come to this location. Check this one with the next one. 0 and 1. Check these 2. Now do not compare 4 and 8. Now values has been changed. Start from here. 1 is smallest. Therefore 1 come to here. 4 come to here. And 3 and 8 as it is. Then go to the next one. When you come to the next one, you have to check the next one. So this one and the next one. That means 4 and 3. 3 is smallest. Yes, you need to set. Then 1, 3, 4, 8. Okay, if you go to the next one, what happened? Next one, you need to check this one. Do we need to check the last one? No, because 8 is already sorted. Because largest value is already there. Therefore, in the second iteration, do not go up to the here. Because you need to only sort these 3 values now. Therefore, do not go this location. Stop it one before. You do not need to compare this one. Okay, then again do that, this one. Now you know here these 2 already sorted. Actually, these 2 also already sorted, but we cannot guarantee. Again, you need to check. How to check? Again, start from here. Check whether this one and this one. Yes, it is. 3 is largest. Therefore, do not swap. Okay, do we need to go up to this one? No, because these 2 already swap. Do not need to check this one. Now this is already sorted. Now this is the mechanism. Anyone has problem? Then how to write the code? Bubble sort. You can use public void, no return type. You need to just sort now. Bubble sort. Okay. Now you know you need to write the for loop should start from 0 to 1 before the last element. Last element is third one, 1 before the third element. Therefore, you can write a for loop for int I equals 0, I less than, assume that you need to go up to this one, then number of elements, up to number of elements. You do not need to go to the last element, because if you go to the last element, you check this one with the next one, here empty value. Therefore, number of element -1. Stop it at this location. And after that, I plus plus. Inside here, what you have to do, you need to, another for loop, you need to compare from 0. That means start from 0, 0 and 1. So how to do that one? You can write another for loop. Int j, okay, j should be, you have to check the 0 and first location. Okay, j should be start from 0 and j less than what? Do you know need to go now? You start from here, no? Do we need to go up to the number of elements? No. Number of elements -1. Go up to the number of elements -1. And there is another one. I come to that part later. After that, j plus plus. Here, what you need to do that one, you need to check whether if array this j location is greater than, j location is greater than array j plus 1 location. If this is greater than, if array j location is greater than array j plus 1 location, you need to swap, because you already wrote a method called swap. You can call the sub method. So you need to pass the element. What are the elements? If this one greater than this one, j and j plus 1 location, you need to swap. So j comma j plus 1 location, you need to swap. Okay, I told you the first iteration should go number of elements -1. So number of element -1, this one. The second iteration, when you come to the first iteration, that 8 come to the here. The largest value come to the here. Then what you have to do, you need to go up to this location. Do not go here. That means the second iteration, then you need to -1 -1. Third iteration -1 -2. Likewise, you have to change. Therefore, how you can change this one? In the first iteration, you do not need to minus anything. Here you have to use -i. Number of element -1. It's better you put the bracket. After that, -i. Initially, I0 mean 0. -1 -0. After that, next iteration, when I become 1, then you have to stop at this point. -i. Anyone has problem up to here? Okay, let's do this one in the NetBeans IDE. Okay, can you guys see my NetBeans IDE? Hello, do you guys hear me? Okay. How you can write this? You have to write a for loop int I equals 0, I less than n elements, minus 1, after that I plus plus. Then second one, start from here. Let's say int j equals 0 and the j less than number of elements, the number of element minus 1 and j plus plus. And yeah, this is should be number of element minus 1 and minus I, because when the first iteration finish, the largest number come to the last position. Therefore, last position is already sorted. Therefore, in the next iteration, do not go up to the last position. Therefore, put the minus I because it is already sorted. Then what you can do here, if array j location, if this j location is greater than array j plus 1 location, then you need to swap. Array j location greater than array j plus 1 location, then swap j location and j plus 1 location. Okay, after you finish, after the outer for loop finish, you can use s out. So numbers are sorted using bubble sort or something. Okay, before going to the next one, let's check whether bubble sort is working properly. How to go, how to do this one? We have to go to the main method and create an object from simple sorting. You can write simple sorting, let's say k or something, whatever the value. After that, simple sorting, here you have to pass the maximum size. Let's say maximum size is 7. Sorry, you have to put the new keyword. Then insert some values. K dot insert, let's say 4. K dot insert, let's say 8. Just copy this value 1 2 3 4 4 8 and let's say 1 and 3. Okay, after that just try to display value k dot display. Okay, now try to run this program. Okay, array content 4813, it is not sorted. 1 4813. Okay, now try to call the bubble sort. K dot bubble sort. Okay, now try to run. Numbers are sorted using bubble sort, but after that again you need to call the display whether it is sorted or not. K dot display. Okay, now you know array content. Previously this is the unsorted array. After that numbers are sorted using bubble sort because you call the bubble sort method. After that display the array content 1348. Now it is sorted using the bubble sort. Anyone has problem up to here? Shall we move to the next part? Selection sort. Okay, now go to how selection sort happen. So selection sort mean, so before going to this one, selection sort, if you take the number of, so as in that this is the numbers, you let's say unsorted numbers. And this kind of numbers available. Then actually what happened in the selection sort, it first come to the this location and check whether what is the minimum value from here, from the other ones. So here you know this is the minimum value. Therefore 1 and 4 will be swapped. Find the minimum value and swap with the first element. That means minimum value come to the first. After that go to the next one and check whether the minimum value from other one and find the minimum value. Then you know minimum value is 2. Then 2 and 7 will be swapped. So likewise, unlike bubble sort, it find the minimum value and put it to the first. And next find the minimum value, put it to the second. හැමතිස්සම මොකද කරන්නේ මේ සිලෙක්ෂන් සෝට් එකේ මිනිමම් එක හොයාගෙන ඇවිල්ලා ඒක දානවා මුල් එකට. ඊගාට මිනිමම් එක හොයාගෙන දෙවෙනි එකට දානවා. So likewise this one happens. So if you go to the selection sort, here 8 and now 8 is our this one, find the minimum value. Now currently 2 is the minimum. Now check where. Now 1 is the minimum. Now take that. Red color is the minimum value. And 0 is the minimum. Now red color is the minimum. After that what? You need to swap with the first element. 0 come to here, 8 come to here. After that, find the minimum from here. 2. Currently 2 is the minimum now. Now 3. 1 is the minimum. Then come to the 1. 4 is not minimum, 8 is not minimum, 7 is not minimum. Now minimum is this one and it is swapped with the second element. Then come to this location, third one. Find the minimum. Currently 2 is the minimum. Check everyone. Okay. Now swap with this one itself. Okay. Now come to this location. Now 6 is the currently minimum. No, 3 is the minimum. After that, yeah, 3 is the minimum. Then swap 6 and 3. So likewise, you know that selection sort, the smallest value come to here, after that smallest value, after the next smallest, likewise it will be sorted until this one. So this is the selection sort algorithm. Okay, let's try to write the code for the selection sort. In the selection sort, what you have to do, you have to write a for loop. So let's say int I equals 0 and I less than number of elements. After that I plus plus. Okay, now when you go to this one, in the selection sort, when you are sorting one by one, first you need to get the, so if I use some annotation, first you need to head to this one. මුලින්ම මෙන්න මේකට head කරන් ඉන්න ඕන. Then find the minimum values from everyone. මුලින්ම මෙන්න මේකට head කරන් ඉඳලා මෙන්න හැම එකේම minimum හොයනවා. So as if the minimum value comes somewhere else, then swap it for with this one. After that head to the this one. මුලින්ම මෙන්න මේකට head කරන් ඉඳලා බලනවා හැම එකේම මොකද්ද minimum එක. Minimum එක head නම් එයා යාවම swap කරගන්න. එහෙම කරන්න අවශ්‍යතාවයක් නැහැ කොහොමද. So if it is this is the minimum one, then swap with itself and go to the next location. That I0, then go to the I1, then go to the I2, I3, I4, I5, I6, I equal 7, I equal 8. When I equal 8, what happened? 0, 1, 2, 3, 4, 5, 6, 7, 8. When I equal 8, you are checking this one and take the minimum value to the here. When you put the minimum value to the here, do you need to check the last one? Check the last one with itself. Do you need to check the last one? No, it is not mandatory, because if you sort up to here, that means if you sort up to this point, the last one is already sorted. Therefore, what you can do is, in your coding, here number of element -1 is enough. Okay. Then what you have to do is, now from all the elements, assume that now you have the 10 elements in the array. Okay. You have to check the all the elements, what is the minimum one. Okay. You have to find the minimum one. Okay. Minimum one means you have to find the minimum index. What is the minimum index? Because you need to swap the indexes, no? Therefore, you need the minimum index. Therefore, you have to declare a variable int, let's say min index. It is the index, not the value. You have to find the minimum index. Let's say minimum index is initially it is 0. 0 means I value. Start from 0th value. Min index is I. Okay. After that, write another for loop to check whether the is that minimum equal I or any other value. First, what you have to do, you have to check this 0. That means this one is the minimum. මුලින්ම මෙන්න මේක තමයි minimum කියලා ගන්න. ඊට පස්සේ මොකද කරන්න තියෙන්නේ? අනිත් ඒවා චෙක් කරලා බලනවා ඒක minimumද කියලා. දැන් මුලින්ම minimum එකකට value එකක් දාගන්න බෑ මුලින්ම. අපිට නැත්තම් කරගන්න බෑනේ. මුලින්ම minimum එකකට value එකක් දාගන්නවා. පස්සේ check කරලා බලනවා මොකද්ද ඇත්ත minimum එක කියලා. First we will use this is a fake mean. Sometimes maybe fake minimum value. Now this is, you are going to find actual minimum value using for loop. You can write int I already taken j equal. Now what you have to do here, you start from this location, then you need to check whether minimum value is equal. That means check. Now let's say annotation. Okay, you head to this one. Now assume that this is the head location. Okay, initially you put this one as the minimum. Initially you put this is the head and this is the minimum location, and you need to check whether the second location, check whether the second location is less than the minimum. If this second location is less than the minimum, then second location should be the minimum. Then go to the next one. If this one is the minimum, then sorry, if this one is less than the minimum, then minimum should be the third location. Sorry, zeroth location, first location, second location, and third location. And check whether third location is less than the minimum, then third location is the minimum. Likewise, you need to do this kind of task. Okay. So, do we need to check the minimum location itself? No. If the minimum location is this one, you need to check the next one and onwards. So, what you can do here, j should be equal, I is 0, I plus 1 location. J should be start from I plus 1. දැන් මෙතනින් පටන් ගත්තාම පස්සේ එයා එයාත් එක්ක මිනිමම් කියලා චෙක් කරන්න දෙයක් නැහැනේ. ඊගාව එක්ක ළඟින් තමයි මිනිමම් කියලා බලන්න ඕනේ. So j start from I plus 1 and j should be less than the number of elements. You have to go up to the last one. අන්තිම එක දක්වාම යන්න එපා. So up to n elements and j plus plus. Go up to the number of elements. Then what you have to do, you have to check whether each one, whether that j location value is less than the minimum value, then minimum index should be the j location. So how to do that one? Check whether if array j location, j start from 1. Okay, if the I is 0, j start from 1. Check whether that one first location is less than the minimum value. Minimum value means min index. So can we use the min index? No, you have to go to that value. Then array min index location. Check whether this one is less than j location value less than the min index value, min index location. Then what you have to do? If such a situation, you have to use, then min index should be j. Okay. Let's give me a minute. Okay. Can you guys hear me again? Hello, do you hear me? Yeah, okay. Now what happened? By using for each enough, that means each j location, you are checking whether j location value is less than the minimum index value, then minimum index should be j. Okay. Then after this for loop finish, after this inner for loop finish, you have the minimum index. What is the minimum one? Then what you have to do? Then you need to swap. That means for an example, let's say some Excel value. Assume that now you have this kind of values available, 5, 3, 7, 2, 9, 6, and yeah, this kind of values. Now this is your array. Okay. Now what you have to do, you have to head to this location. You need to head to the let's put the location numbers also. This is the 0, 1, 2, 3, 4, 5. This is the location, array location 0, 1, 2, 3, 4, 5. Now what you have to do, you need to head to this location. That means this is the I. How to draw the I? Okay, now this is the I location. I head to this location. And from the J value, J come from here and onwards. J go from here to here. Okay, J go from here to here and find what is the minimum value. Find the minimum location. Now you know from here to here, first check whether 3. Compare 3 with the 5. No, 3 is the less. Then minimum is 3. Then how it's happened? Initially minimum is 0th location. Initially minimum is 0th location. Now J come to the first location. Now first location is 3. 0th location value is 5. So 3 is less than 5. Then minimum should be 1. Then this one has been changed to the 1. Previously it is 0. Now it has become to the 1. 0. Now it is 1. After that, go to the J second location. It is 7. Minimum is first location 3. 7 is larger, therefore that is not the minimum. Then go to the J comes to the third location. Here you can find 2. Third location value is 2. Currently minimum is first location value. First location value is 3. 2 is less than 3, therefore minimum should be this one. Therefore change the minimum to the 3. Okay, actually that's happened in here. Change the, if it is less than, minimum index should be J. So likewise what happened, now go to the this one, J fourth location. Fourth location is 9. Third location is 2. Minimum is 2. Third location. Therefore do not take the fourth location as the minimum. Then go to the fifth location. Fifth location is 6. Currently minimum location is 3. It is 2. 6 is greater than, therefore do not take the 5 as the minimum. Now when this one is finished, then that inner for loop finished, you have the minimum location. So minimum location is 3, third index. Then actually what you have to do, this third index value you need to put it to this location. That means you need to swap. That means this location and this location you need to swap. This location is I location and this location is minimum location. This is the I location. That means outer for loop location. And index number I and the minimum location is 3. This is the min location. Min location. You need to swap this 2. So how to swap? How to swap this one? when the outer for loop inner for loop finish, here you have to sap what I location and the minimum location, I and the min index location. Because you already wrote the code to sap with I and the minimum location. So this is the code. Anyone has problem? I think it's better you mute your microphone. Okay, then the outer for loop finish, you can write system.out.println. Just copy this one. System.out.println. Numbers are sorted using not the bubble, selection sort. So this is the selection sort algorithm. Selection sort means select the minimum and insert it to the relevant location. Select the minimum, always select the minimum and insert into the relevant location. That is why it put it as selection sort. Okay, now try to do this one. Instead of bubble sort, use the selection sort. Selection sort, then run. Array contain 4813. Numbers are sorted using selection sort. After that 1 3 4 8. Anyone has problem up to here? No problem. Shall we move to the last algorithm, insertion sort? Okay, check whether how the insertion sort working. Here. First check this one and check whether 5 is the minimum, put the 5 to the here. Then go to this one, check whether what is the location. 3 should be come to here, then you need to that shift the element to the right. The 1 should be come to this location. Then other 3 elements should be swap. Not the swap, should be shift. Now 8 is in the correct location. Put it as it is. 7 should come to this location. Then take the 7, shift 8 to here, put 7 to here. Then 3. 2 should be come to this location. This location means shift the 8, shift the 7, shift the 6, 5, 3 and 2 should be come to this location. Now the last one, 4. 4 should be come this location. Then shift elements one by one and put the 4 to the here. So this is we called as insertion sort. That means first of all, it starts from 6. 6 should be same location and actually it should not start from the 6, it should be start from the second location. That means second location and onwards you need to check and check whether that second one where it should be the location. So did you identify the algorithm? Okay, let's write this one. Let's explain this one using Excel. Assume that now you have the values 4 3, 5, 2, 9, 6. Assume that those are the values and array indexes are 0, 1, 2, 3, 4, 5. Okay, now what you have to do is that mean array should start from this location. So do not start it from here, because this is we need to check this one, find where is the location. 3 should come to this location. What happens if you start from here? 4. You need to find 4 where is the location. Here the part is empty. This is our array out of bound. Therefore, what you have to do is you have to start from this location. Okay, 3. You know 3 should come to this location. Okay, when 3 should come to this location, you need to shift 4 to here and insert 3 to here. This is not a sap, okay? Make a sap pack හිතන්න මෙතන එක sap pack වගේ පේනවා. හැමතිස්සෙම sap pack නෙමෙයි වෙන්නේ. This is not a sap. Okay, then what happened? I will redraw this one. You need to take 4 to here. Take 4 to here. Okay, then what happens when you take the 4 to here? 3 will be erased. Therefore, before take 4 to here, take 3 to let's say it is a key. Key is the 3. Take that 3 to some value called key. Then shift this 4 to here. After that, insert this 3. That means insert this key to here. Okay. Because this happens when you come to this location. Now you put 3 to here, 4 to here. Now you know 3 and 4 already sorted. This one has been already sorted. Therefore, I put it in the color. Now what you have to do, now go to the next location, second location, 2. What is the value? 5. 5, where is the location? Is it in middle of this one? No. 5 should be as it is. Therefore, put the 5 at this location. Do not insert into the any location, any middle of this one. This is the location. So put it as it is. Then what happened? You know, this is all also sorted. Then go to the next location. When you come to this location, now value is 2. 2, where is the location? 2 should come to this location. That means beginning of this location. That means all these values you need to shift to the right. So what you can do is, first of all, take this 2 to the key, not the index value. Take that value to the key. Now shift. I may value එක මේ key එකට ගන්න. මොකද මේ shift කරද්දි පහ මෙහාට එද්දි මේ දෙක කියන එක අයින් වෙලා යනවා. ඒකින්ද මේ මොකක් හරි temporary location වල you have to put this 2 to a temporary location. Here I put the temporary location as key. Okay. Now what happened? I will redraw this one. You need to shift this 3, copy and paste. Shift. 5 come to the here, 4 come to the here, 3 come to the here. So here, when you shift this under the 3, the original 3 as it is. Then what you have to do? Then you have to put this key value to this location. Now what is the key value? Key value is 2. put the 2 to this location. Now you know this one already sorted now. Anyone has problem? Now go to the key, next value. Next value mean now come to this location. I is 4. When I is 4, what is the value? Key is 9. Okay, you have to check wherever the 9 location. 9, do not insert any of this location. 9 should be as it is. Therefore, now this is already sorted. So what you can do, you can color this one. Then come to the last location. When you come to the last location. Now 6. Okay, let's say different value. I think if you put the 6, 1, 2, 3, 4, 5. So assume that this value is 4. This value is 4 and this value is 6. Otherwise, it is already sorted. No, this value is 6 and this value is 4. Then actually what happened? You need to 3 put to the here and 6 come to the here. After that, this one 5 come to the here. Here 5 and 6. Now you count the 2, 3, 5 and 6 and here 4. Okay, now assume that now you come to this location. Now you have the 4th location. So 4th location, that means value is 5th location, value is 4. That 4 value you need to put to the in between 3 and 5. 3 and 5 mean what is the location you need to put? You need to put this 4 to this location. Then actually what you have to do, this 5, 6 and 9 you need to shift. So how to shift? I will copy and paste this one. Take that 4 as the key, 5th location value. Now 4 is your key. Before shifting, take that value to here. Then what you have to do, that the value should come to this location. That 4 should come to this location. Therefore, 5 and onwards you need to shift. This 5 and onwards you need to shift to the here. Then what you have to do, then this key value you need to put this location. Key value is 4, put that 4 to this location. 1, 2, 4, 5, 6, 9. Likewise, this insertion sort works. Okay. Now go to the coding part. When you come to the coding part, you have to write a for loop. Int I start from, when you start from this one, I should be start from first location. First location, take the I as first location. 3, check whether 3 you have to put this one. Do not start I from 0th location. What happens if you start the I from 0th location? Do you have any previous location to put that 6? No. Therefore, start from first location. 3. 3 should come to this location. So I think you understand that part. Therefore, I should be start from first location 1. Then I less than number of elements. After that, I plus plus. Okay, now what you have to do here, you have to write another for loop or while loop or whatever the one. Before writing the next loop, you have to put your that I location, that what you put here, you have to put this 3 to a temporary location. So how to put this one? You can declare a temporary location. Let's say int key means the temporary location is equal array I location. Whatever the I location value, put it to this location. Then what you have to do, I will write now here what you have to do, assume that this is the last element. Now you are going to swap. So not the swap, you are going to insert. Now assume that I is in the last location. Now when I is come to the last location, what you have to do, you have to write the inner loop from here and onwards. Inner for loop should start from this location. That means I minus 1 location. I minus 1 location. What you have to do, this one, here you need to check whether this 9, check whether it is greater than key. Your key is 4. If it is greater than key, shift this one to the here. Okay. Then come to this location. Now 2. Check whether 2 is, sorry, not the 2. When you come to here, this is the value 6. Check whether this 6 is greater than the key. Yes, 6 also greater than. Therefore, shift. So previously you shift this one to here. Now shift 6 to the here. 9 come to here, 6 come to here. Then go to this one. What is the value? Second location, value is 5. Check whether the 5 is greater than this key. Yes, 5 also greater than key. Therefore, shift this one to the here. Okay, then go to this one. Now what happened? Now J is this location. This is the J. J is this location. What is the value? 3. J means first location. Location number 1. Value is 3. 3 is it greater than 4? No. 3 is not greater than 4. Therefore, do not shift this one to the here. Now you find this location. Now what you have to do? If it is not greater than, you need to put this 4 to this location. What is this location? This is J plus 1 location. Now J is 1. J plus 1 location means 2. Put that 4 to J plus 1 location. Okay. So what you have to do, initially you have to start the J from I minus 1 location. Now I පහනම් 4 ඉඳන් පටන් 4 ඉඳන් මේ පැත්තට යන්න ඕන අනිත් පැත්තට. If I is 5, J should start from I minus 1 location. Then how to do this one? You have to write int J should equal I minus 1 location. Okay, then I will write a while loop. If you want, you can write a for loop, it doesn't matter. While loop, what is our condition? Let's say our while loop, let's say condition, however, while loop should end at first location. Actually, we can't find what is the end first location. Therefore, let's say we go up to the 0th location, but do not go up to the 0th location. You have to finish at first location. Here we write this one, let's say j less than or equal 0. Assume that we go up to the 0th location. But remember that do not go up to the 0th location. Middle, you have to stop. Okay. Now what we are going to do here, we need to check this j location. That means j location is greater than this key. Sorry, j location value. J location value is 9. 9 greater than this 4. How to check this one? You have to write if array j location is greater than key. Okay, j location is greater than key. If this j location greater than this key value, so which mean so assume that now this is the j location. If this j location mean 9, 9 greater than, so I draw it in here, 9 greater than 4. Yeah, if 9 greater than 4, you need to shift this 9 to this location. That means now this is your j location. How to shift 9 to the here? That j plus 1 location should be equal j location. That is how you shift. How to do this one? You have to shift this one, array j plus 1 location is equal array j location. Okay, likewise you have to go up to this point. Up to this point, you have to go up to this location. Sorry, this location. Here, when you come to this location, 3 is not greater than 4. Then you have to stop. Do not go beyond this one. Then shift කළ තේරුමක් නැහැ අපිට කොහොමද? මෙතනින් නවත්තන්න ඕන. When j is 0, you have, sorry. When j is 1, according to this example, when j is 1, you have to stop. Stop mean if this array j location is not greater than this value. Here it is not greater than 3, not greater than this value. If it is not greater than this value, you have to stop the loop. So how to do this one? Not greater than. Here, if this one greater than the key, so I'll remove this part. Okay. If this one greater than this one, you need to shift. Else mean not greater than. Else mean not greater than. If it is not greater than, what you have to do? You need to break the loop. Here you have to find break. You have to put the break. Stop the while loop. Okay. Now what you have to do? When one iteration finish, you have to use j minus minus. Because you have to shift from 1 by 1. J first come to here. After that j minus minus, j minus minus. Likewise, you have to go 1 by 1. Okay, once this one finish, once this while loop breaks, then what you have to do? according to this example, when j come to this location, your while loop breaks. Then actually what you have to do, this 4 should come to this location. Now 5 you have shift to the here. Now you have to put this 4 to this location. The 4 should come to this location. This location, that is why in the next one 4 come to the here. Okay, now this is your I. Sorry, this is your j. Now j is available here. Now how to put the 4 to here? J plus 1 location. This is the j plus 1 location. Put that key value to the j plus 1 location. So when the while loop finish, here you have to use array j plus 1 location should equal your key value. Then this will be shifted to the proper location. So not the shifted, it will be inserted to the proper location. That is how insertion sort works. Okay, this is the end of the insertion sort. Now try to run the insertion sort. Here you can write dot insertion sort. Okay, run this program. Before 4813, after the insertion sort 1348. So this is the insertion sort. Anyone has problem up to here? So you can write this one without the break statement, which means here you can use another one condition. Here you can use and array j location greater than key. Likewise, array j location greater than key. That means this condition also you can put. If this is greater than key, only go this one. Then you do not need this break statement and if statement. That is also work. So if you are expert in how to write the code, then you can write it in this way also. So I think you may not understand what is this two condition. That is why I put it in separate way. Likewise here. Likewise here. So you can use whatever the way you like. So, but the pattern should be find the minimum find the correct location and insert. That is the pattern. Find the correct location of that value and insert. So anyone has problem up to here? So today's lab session covers only the simple sorts, not the advanced merge sort, quick sort or heap sorting part. So and actually this is the end of the lab session. Anyone has problem up to here? If you don't have any question, I can wind up the class. No questions. And before stopping the lab session, I need to uh, give some instruction to the IT students, not for IT and M and not for this subject. For IT students who are doing the computer networks, the next Tuesday you have an assessment. So remember that for the computer network students, so this is not relevant to IT and management. So they guys do not consider this one. So what is that computer networks part? So actually my Moodle is not working properly. Okay, in the computer networks, next week you have an assessment. So read the entire paper before attempting all the questions. You need to read the entire attempt, sorry, entire question paper. And there is another one. So you need to use the packet tracer, whatever the version available in the Moodle. Here. So Cisco packet tracer use the 6.0.1, whatever the version available in the Moodle. And only exceptional cases will be given for the Mac users. They can use the latest version, 7 version. So, and if you have the 7 version, any student who are using the Mac, you need to provide you an index number through a batch representative to me. Okay, provide your index numbers to me for the Mac, only Mac users. So they have only Mac users are allowed to use the 7.0 because this version is not available for the Mac operating system. Okay, for Windows operating system, you need to use this version. Okay, in case assume that for the Windows users, assume that for a system corruption, whatever the reason, this version is not working, then separately inform to the batch rep, I am using the Windows and I am using the packet tracer version 7. Okay, usually you do not allow to use the packet tracer higher version rather than this version. If you are Windows users in such a situation, assume that this version is not working. If you are using a higher version, so inform it to the batch representative because I need to provide the relevant packet tracer version to that index number. And so this is the uh, instruction for that one. So this is not relevant to the data structures. So therefore ITM student, IT and management student do not get that part. Okay. Up to here, do you have any problem regarding the sorting algorithms? Okay, seems to be there are no any questions available. Okay, then I will wind up the class. So thank you for the participation.